In this video, I am going to explain about model questions of P block elements, that is group 15 to 18. Here it is first question. Excess of lithium and magnesium are allowed to react separately with 1 mole of N2 gas. Ratio of gaseous product obtained in complete hydrolysis of both the compounds. So first lithium reacts with N2 to form Li3N. So take here 2 moles, here 6. Next Mg. Mg plus N2 gives Mg3N2, 3 Mg. So lithium nitride and magnesium nitride. So which on hydrolysis will give LiOH thrice plus NH3. So here 2 nitrogen atoms are present, therefore 2 moles. So lithium atoms 6, therefore 6 LiOH thrice. Next here also H2O, MgOH twice plus again 2NH3. So Mg3 means 3 moles. So therefore ratio. So gas is here ammonia gas. So therefore ratio is ratio of gaseous product equal to 2 moles ammonia is to 2 moles of ammonia. Therefore 1 is to 1. So option C. Next. Select incorrect statement about ozone. Here ozone must be there. Ozone. So you know ozone is bent molecule. Like this you can write. And here day 2 bond. Here 1 pair. So here 2 pairs. And here 3 pairs. So bent or angular or V shape. So bent molecule, which is correct. Next bleaching agent. So O3 dissociates to O2 plus O. So due to nascent oxidation, it is bleaching agent. Next powerful oxidizing agent, bleaching agent and oxidizing agent. So all these are correct. A is correct, C is correct and D is correct. So paramagnetic is wrong. So O3 is diamagnetic. All are paired electrons. Diamagnetic due to paired electrons. If all are paired electrons, O3 will be diamagnetic. Therefore, option B is incorrect. Next. Which HX gives peroxide effect in the presence of H2O2? So peroxide effect or anti-Markovnikov's addition. Peroxide effect or anti-Markovnikov's addition. Anti-Markovnikov's addition or Kharash effect. Kharash effect. So it is observed only in case of HBr. Only in case of HBr plus peroxide. So we'll discuss this topic in organic chemistry. So very important. So because all possible reactions are here, all steps are exothermic. In reaction mechanism, all steps are exothermic. Therefore, anti-Markovnikov addition or peroxide effect or Karash effect is possible only with HBr with peroxide. So option B. Next, select correct order of dissociation constant in aqueous solution. Dissociation constant Ka. That means Ka is acid dissociation constant. Acid dissociation constant. So as the Ka value increases, acidic nature also increases. So acidic nature order H2Te, H2Se, H2S and H2O. So bond length increases in this order. So therefore Ka also will be in this order. Therefore acidic strength. Remember like this. H2T is most acidic due to more bond length. So more is the bond length that can dissociate and that gives H plus ions easily. Therefore option B. Next. The number of S double bond O's and SOH bonds present in peroxy disulfuric acid. Peroxy disulfuric acid and pyrosulfuric acid. So peroxy disulfuric acid is H2S2O8, which is also known as Marshall's acid. Next, pyrosulfuric acid H2S2O7, so which is also known as disulfuric acid. So disulfuric acid or oleum. These are different names. So I will write structure S double bond O's and OO, OH and OH. So they are asking about S double bond O's, SOH. So S double bond O's equal to 4 and SOH bonds 2. Next here similar structure OH and OH. So here also same. Therefore SO bonds 4 and SOH bonds 2. Therefore 4 2 and 4 2. So option D. Very very important. Next. Which of the following reactions is an example of redox reactions? Redox. So check XeF4 plus O2F2 dioxane difluoride gives XeF6 plus O2. So this is most important preparation of XeF6. Next here Xe oxidation state plus 4. Here O2, that means for each oxygen plus 1. Here plus 6 and here 0. Check here plus 4 to plus 6. So plus 4 to plus 6 oxidation, increase in oxidation state. Oxidation and Okay, +1 to 0, decrease in oxidation state, reduction. So both are taking place in same reaction. Therefore, this is redox. Redox reaction. Option A. Xenon undergoes oxidation and oxen undergoes reduction. Next. Chlorine water on long-standing loses its color and forms. Chlorine water. That means Cl2 plus H2O. Chlorine water on long-standing gives HCl plus HOCl or HClO. So hydrochloric acid, we know this one hypochlorous acid. Hypochlorous acid, powerful oxidizing agent. So here HCl is stable, we know, and HOCl unstable. So therefore it dissociates to give HCl plus O. So due to nascent oxygen, it is powerful oxidizing agent. So this is complete information about HOCl. So first it forms HCl and HOCl. Option D. Next. The products formed when chlorine gas reacts with cold and dilute aqueous NaOH are Cl2 reacts with NaOH, which is cold and dilute, forms NaCl, NaClO plus H2O. So balancing here 2 moles of NaOH. So balance. Next, here Cl2 oxidation state 0, here Cl minus 1 and here plus 1. So this is best example for disproportionation reaction. So this is sodium chloride and this one sodium hypochlorite. So in this ion will be Cl minus and in this ion ClO minus. Hypochlorite ion and chloride ion. So best example for disproportionation. So therefore option C. Cl minus and ClO minus. Chloride and hypochlorite. This one chloride and hypochlorite ion. Next. Which among the following is most reactive? If you take I2, that will be I and I, charges 0. Cl2 also similar, Cl bond Cl, charges 0. Br2, Br bond Br, charges 0. That means these are completely non-polar or pure covalent bond. Therefore unreactive, least reactive because the absence of charges. Next, about ICl. ICl is polar. So delta minus and delta plus. This is polar covalent. Therefore, more reactive. So, polar compounds are more reactive when compared to non-polar compounds due to the presence of charges, partial charges. Therefore, B, ICl. Next. So determination of molecular mass of acetic acid in benzene using freeze-in-point depression is affected by. So acetic acid in benzene C6H6. So which is non-polar solvent. Undergoes dimerization. CH3COOH twice. If you take 2 moles. Dimer due to formation of intermolecular hydrogen bonding like this. Molecular association takes place. Double bond O and OH. Here there is formation of hydrogen bond. So molecular association. That forms dimer. Therefore, molecular weight is affected by dimer formation. So molecular weight of acetic acid we know 60, but due to dimer formation we will get molecular weight 120. Therefore, association can affect boiling point and molecular mass also. Next. So which gas produces brown coloration when passed through aqueous solution of FeSO4? This is famous. So Fe H2O 5 times NO SO4 will be formed. Brown ring. Brown ring formation. Here SO4 minus 2 and here NO plus 1. Then iron will become plus 1. So NO forms brown ring with Fe2 plus. So iron oxidation state will be plus 1, not plus 2 due to NO plus. So option A. So this is brown ring test. Next. Ions present in KiBrCl. KiBrCl use K plus I Br Cl minus total. So this is polyhalide ion. So this is completely one ion. Only one ion. Therefore K plus I Br Cl minus. So option A. One anion, one cation. So this is best example for interhalogen compounds or polyhalide ion. Next. So Br2 plus 2x minus gives x2 plus 2Br minus. The above reaction is correct when x minus is. So here Cl2 or first I will write F2 can displace Cl2, Br2 and I2. Cl2 can displace Br2 and I2. Br2 can displace only I2. I2 cannot displace any halogen. So therefore, reactivity order we can say F2, Cl2, Br2, I2. Reactivity. Very, very important. So here Br2 can displace only I. So therefore, X is I minus only. Option B. Here X minus must be I minus. And it gives X2 which is I2. Very, very important. Next. So N-hydride of nitric acid prepared by reaction of HNO3 and P4O10. So HNO3 reacts with P4O10 phosphorus pentoxide which is dehydrating agent. Dehydrating agent. So loss of water molecule. So take here 2 moles minus H2O gives N2O5 dinitrogen pentoxide. So we can write N2O5 as NO2 plus and NO3 minus. In solid state, it exists as ionic form. So nitronium nitrate. Nitronium nitrate. Next. So in this cation is sp hybridization, that is linear, and anion is sp2 which is planar. Trigonal planar. Trigonal planar. So therefore cation linear, anion planar. So both are correct. Very, very important. Nitronium nitrate ion. Next. The solution of HgCl2 mercury chloride reacts with PH3 gas to form. This is also very, very important. HgCl2 mercury chloride reacts with phosphine gas to form Hg3P2 plus HCl. So after balancing, here 3 moles, here 2 moles, and here 6 moles. So this is black PPT. Mercuric phosphide. Mercuric phosphide. So option C, Hd3P2 will be formed. Next. So mixture of which gas produces blue liquid on cooling at minus 30. So here NO gas combines with NO2 gas at minus 30 degrees centigrade forms N2O3 which is blue liquid. So dinitrogen trioxide or nitrogen sesquioxide. Nitrogen sesquioxide. So option D. This is best method of preparation of N2O3. Next. So which of the following must be present in alums? So alums general formula M2SO4 and M dash 2SO4 thrice 24H2. So best example, potash alum. Potash alum can be written as K2SO4 Al2SO4 thrice 24H2. K2SO4 Al2SO4 thrice 24H2. So this is potash alum. There are two types of ions will be there. So here monovalent oxidation state +1 and here +3. Sulfate -2 we know. So here 2K plus SO4 2 minus 2Al3 plus 3 SO4 2 minus. These are the ions. Next. So here K will be, K means here M. Coordinates with 6 water molecules and similarly Al also. H2O 6 times 3 plus. Each ion coordinates with 6 water molecules. Coordination number 6. Here also coordination number 6. So for 1K plus 6, 2K plus K plus ions 12. Each aluminium 6 coordination number, 2 aluminiums 12. Therefore 12 plus 12, 24 water molecules. That means we'll have M plus 1 H2O 6 times plus and M oxidation state 3 H2O 6 times 3 plus. These are the ions. So very important topic. Each ion has coordination number 6. So therefore option D. Next. So which of the following is aquaresia? So aquaresia is 3 parts of concentrated HCl plus 1 part of concentrated HNO3. So that means we can write 3 parts of HCl, 1 part of HNO3 gives NOCl, nitrosyl chloride plus 2H2O plus 2Cl. Nascent chlorine. So it can dissolve noble metals. It can dissolve noble metals. That is gold and platinum. Very important. So what is the use of aquaresia? To dissolve noble metals, gold and platinum. Option A. So due to the presence of nascent chlorine, it can dissolve noble metals. Next. So which of the following does not produce NO2 gas with concentrated HNO3? So this is also important. Gold and platinum does not react with concentrated HNO3. So these two are noble metals. So these are unaffected by most of the reagents. Therefore, AU, D. Remaining can react. Next. So noble gases have atmospheric abundance 1%. That means composition of air 78% of N2. Next 21% of O2. So here 99, 1% of noble gases approximately. So this is by volume, in terms of volume. So in 1%, 0.93% of argon is present. Therefore, argon is most abundant. Major constant, select the option. That means here argon. It should be argon. Major constituent of air is argon, which is option C. Not xenon. Major constituent of atmosphere is argon. Argon. Option C. Very, very important. Okay, next. When SO3 absorbs in concentrated H2SO4, it produces. So H2SO4 concentrated plus SO3 gives H2S2O7. So which is known as oleum or pyrosulfuric acid or disulfuric acid. H2S2O7. Very, very important. So pyro form of acid will be produced. Structure will be like this. S double bond was and the SOS bond is present here. So this is the structure. H2S2O7. Next. Select the periodic property not regular. Not regular in halogen family. On moving down the group. So down the group. Ionization energy, halogen family F, Cl, Pr and I. So ionization energy in this order, that is regular. Next, size. Size will be like this. Down the group, size increases. Next, electronegativity. Electronegativity. Fluorine is most electronegative. These are regular. But electron gain enthalpy order. Electron gain enthalpy order is Cl, F, Br and I. It is not regular. Ionization, size and electronegativity are regular. So here irregular, not regular. So this is due to small size of fluorine. Small size of fluorine. Therefore, option D. That means statement 2. Next. So which are the following reaction cannot change SO2 to SO4 2 minus. Cannot change SO2 to SO4 2 minus. See here. First one, SO2 reducing agent, MnO4 minus oxidizing agent. Therefore, SO4 2 minus will be formed. Here SO4 2 minus will be formed. Next, here also Cr2O7 2 minus oxidizing agent. SO4 2 minus will be formed. Next, Fe3 plus also oxidizing agent. Therefore, it can also form SO4 2 minus. Next, last reaction SO2 plus BaOH twice. So this is base and acid. Simply neutralization reaction. BaSO3 plus H2O. Barium sulfite. That is Ba2 plus SO3 2 minus. So this is acid base neutralization. Therefore, BaOH twice is not oxidizing agent. So oxidizing agent can convert SO2 to SO4 2 minus. But here BaOH twice is just base. This is acid base neutralization reaction. Therefore, BaOH twice cannot convert SO2 to SO4 2 minus. Therefore, option D. Remaining MnO4 minus Cr2O7 2 minus and Fe3 plus are oxidants, oxidizing agents. Remember this point. Therefore, D option. Next. So, a number of moles of pH bond produced by 1 mole of white phosphorus completely reacts with KOH solution is. So, this is also very important. So, number of molecules. So, here white phosphorus means P4 reacts with concentrated solution of KOH. Solution means H2O must be there. So KH2PO2 plus pH3. So balance 3 moles of KOH, 3 moles of H2O. Next here 3 moles of KH2PO2, potassium hypophosphite and pH3. This is phosphine gas. So 1 mole of white phosphorus reacts with here 1 mole. So how many moles of pH bonds? So here I will write structure. pH3 structure. This is pH3 structure. And here next here O minus and K plus. So this is pH3 and K H2PO2. Now check 1 mole of P4 white phosphorus can release. So here 3 moles it is producing. Here pH3 1 mole is produced. 1 mole means 3 moles. 3 moles of pH bonds. Next here 3 moles. So 1 mole contains 2 pH bonds. Therefore 3 moles means 6 moles of pH bonds. Therefore total 3 plus 6, 9. 9 is the answer. 9 moles of pH bonds. Very important. Most important question. Next question. The number of moles of NaOH required for complete neutralization of H plus in solution, which is formed by hydrolysis of 1 mole of PCl5. So 1 mole of PCl5. First I will write hydrolysis. 1 mole of PCl5 undergoes hydrolysis to form H3PO4 plus HCl. After balancing, here 1 mole gives here 1 mole and here 5 moles. So here 1 mole contains 3 H plus ions and here 5 moles contain 5 H plus ions. So total 8 H plus ions are present. 8 moles of H plus ions. 8 moles of H plus ions will be equal to 8 moles of NaOH or 8 moles of OH minus ions. So 8 is the answer. Very, very important. So 1 mole of H3PO4 contains 3 H plus ions. We will write structure also. OH, OH and OH. Delta minus, delta plus, delta minus, delta plus. So delta minus and delta plus. 1 mole contains 3 H plus ions. H3PO4, orthophosphoric acid. You know HCl contains 1 H plus, 1 mole 1 H plus. Next. So at 143 Kelvin, the reaction of XeF4 plus O2F2. So XeF4 plus O2F2 gives XeF6 plus O2. Produced a compound Y. So this is Y. The total number of lone pair of electrons present on whole molecule of Y. We'll write structure Xe. So this will be distorted octahedral. Fluorine, and here one lone pair will be there. Next, on each fluorine, we know 3 pairs. Each fluorine, 3 pairs. Now check. Each fluorine has 3 lone pairs. So therefore, total number of lone pairs equal to, so total number of fluorine 6. 6 into 3. So plus 1 lone pair on xenon. Therefore, 19 lone pairs total. 19 lone pairs. Next. Number of oxides of nitrogen which can produce HNO3 when dissolved in water. So first I will write. First I will write NO2. NO2 plus H2O gives HNO3 plus HNO2. So NO2 is mixed oxide or mixed anhydride. It is forming nitrous acid, nitric acid. Next. Next one. N2O4. N2O4 plus H2O, similar reaction. HNO3, HNO2. So it is a dimer of NO2. Both are same. Dimer of NO2. Next, N2O5 plus H2O gives 2 moles of HNO3. Next, N2O3 gives 2 moles of HNO2, and this produces HNO3 on disproportionation. Proportionation. So therefore, NO2, N2O4, N2O5 and N2O3 can produce. Therefore, total number of oxides 4. So this can produce HNO3 on disproportionation. Total 4. Next. So how many moles of PH3 gas produced when 1 mole of calcium phosphate reacts with excess of water? Calcium phosphate Ca3P2 plus H2O gives CaOH twice plus PH3. Here 3 moles and here 2 moles. Total number of hydrogens 6 plus 6, 12. That means 6 moles. So here 1 mole produces 2 moles of phosphine gas. So very important. Therefore 2 moles. Next. So maximum number of halogen atoms are possible in uncharged interhalogen compound. So that is AX7 form, which is IF7. Iodine heptafluoride. This is interhalogen compound, one type. So therefore number of halogens 1 plus 7 equal to 8. Maximum 8 is uncharged neutral molecule. AX7 type of interhalogen compounds will be having maximum of 8 halogen atoms. Iodine heptafluoride. So structure will be pentagonal bipyramidal. Pentagonal bipyramidal geometry. Remember this point also. Next. So I think this is repeated question. Maximum number of halogens are possible in uncharged interhalogen compound. I will write once again in detail. Interhalogen compounds are 4 types. Interhalogen compounds. Next, here for AX7, IF7 is the example, iodine heptafluoride. Iodine heptafluoride. So therefore number of halogens equal to 1 plus 7, which is 8. So 8 is the answer. So this is the end of the chapter P block 15 to 18. In next video, I will explain one more chapter. All the best and thank you.